In this tutorial, we're going to learn how to calculate correlations, and specifically a correlation matrix, in order to assess the criterion-related validity of different selection tools with respect to a criterion of interest, where a criterion is often going to be some indicator of job performance for a particular job. So let's assume that these data that we see here in this Excel worksheet here, that these data belong to a concurrent validation design, which is used to assess the criterion-related validity of the job of, let's say, a customer service representative for these specific selection tools or assessments or tests or however you want to call them. And so here we have three different variables that correspond to the selection tools, tests, or assessments. Again, you can call them whichever you'd like. And so we have proactivity, personality inventory here, an emotional intelligence test here, and an SJT, which stands for a situational judgment test. Now, our criterion of interest, because this is criterion-related validity, is going to be customer service. So this is the performance indicator we're interested in. Now, what you'll see here if you scroll down through these data is that we have 300 people participated in this concurrent validation design, or in other words, this concurrent validation study that is meant to assess the criterion-related validity of these three selection tools in relation to this criterion of interest. And again, a correlation coefficient is one way that we can represent what we call a validity coefficient. Okay, so it's our estimate of criterion-related validity between one selection tool and the criterion of interest. So how do we access it? Well, the first thing that you're going to need to do, if you haven't already, is to make sure that you've installed the data pack in Microsoft Excel. Now, if you are using something other than Microsoft Excel, such as Google Sheets, or you're using Microsoft Excel for a Mac operating system, then you'll likely need to follow the steps that I'll present in the second part of this tutorial video. So if you go to Data, and you look all the way over to this analysis section, if you see data analysis here, this means that you have the data analysis tools or the analysis Toolpak access. Now, how do you get that? Well, in order to access that data analysis Toolpak, you should go to Options, okay? And go down here to Add-ins. Click there, and you'll notice that there is an analysis Toolpak. So you may need to add this in by selecting it. I've already selected it here. It's an active application add-in. If you have Microsoft Excel for Windows, this is not anything you need to pay for. It's something that actually comes standard with your download and installation. You just need to actually make it active in your Microsoft Excel. So notice this is different from the Analysis Toolpak VBA here. This one is just the Analysis Toolpak. So you'll want to make sure that you add this in, and when everything's ready, you click OK here, okay? And once you do that, you should be able to go over to Data, and you'll see under Analysis that there's a Data Analysis section here. If you want more details on how to download this, check out the written version of this tutorial, and I have some screenshots that you might find helpful. So let's go to Data Analysis here, and actually I'm going to click right up there. And so this will be just, you can put your cursor wherever you want, but I'm going to click here on Data Analysis. You'll see that a window pops up here called Data Analysis, and then you see Analysis Tools. And you'll see there's a number of different analyses. We have some basic descriptive analyses, as well as some such as descriptive statistics here. And we also have some inferential statistics as well. Now, we're going to be interested in the correlation here. Okay, so this will help us create a correlation matrix. And if you're not familiar with what a correlation matrix is, well, you'll see one in just a moment. So let's go ahead and click OK here after we've selected correlation. Okay, the next thing we're going to need to do is we're going to need to select the columns. If we go to input range here, we can click there, and we are going to select the columns that contain the data, or the variables specifically with the data below, that we're going to use to create our correlation matrix. So in this case, it's columns A through D here. So we've selected. And we're going to note that we've selected the data by columns. And what this means is that the way the data are structured here is that columns represent unique variables here. So proactivity has a unique variable and so forth. Oops. shouldn't have clicked there, so it just undid that. Again, we just have A through D in terms of the 4 columns there. Now we're also going to want to click this box because in these data, our first row here has the labels for these variables, or in other words, the names for these variables here. Okay, so the next thing that we're going to need to do, it's not much work here when you're using this correlation matrix function from the analysis Toolpak. The next thing we do is we go down to output options, and you'll see it's auto-selected in most cases already. You'll see new worksheet ply, and what this means is a new tab down here. So let's keep that option here, and let's type in the blank here, a name. I'm just going to type in, let's say, correlation matrix. You could type in whatever you want here. You don't have to type in a name either, but I think it's helpful to do that. Okay, so go ahead and click OK. Be a second. And so this just opened up a new worksheet ply or tab down here at the bottom. I'm going to scale this up for you, magnify it so you can see this. And I'm also going to adjust some of the cell settings here so we can see the full names, a little bit easier to read here. Okay, so here's a correlation matrix. One thing that's helpful sometimes too is that that's a lot of decimal places displayed there. Well, if you go to home and we click on this button right here where it says decrease decimal, or you could click on this right here to get a window and do this manually. You could go to number and change the number of decimal places, but let's do it here. And, oh, there we go. So you might have to toggle between these here. Sometimes you have to increase to decrease. Alternatively, you could go to number and select how many decimal places you'd like to report to. So here I'm just choosing 2. It's fairly conventional, 2 or 3 decimal points here. Okay, so how do we interpret this? Well, it's a matrix. And so you'll see that we just have the values for the lower diagonal here, so we don't have the upper diagonals here. Why is that? Well, it would just be a mirror image of the lower diagonals, and you'll see here in a second why that's the case. So you'll notice on the off diagonal here, we have correlations of 1, 1, and 1. Now, if you remember about what a correlation is the sign and the strength of the association between 2 relatively continuous variables, or at least in this case, it's a Pearson product moment correlation, so that's what it indicates. So here, a correlation of 1 positive means there's a perfect positive correlation between these 2 variables. Well, does that make sense? Well, yeah, it does in this case, because we're correlating proactivity with itself. So anything correlated with itself is going to be perfectly correlated with itself and positive. So here we have, that's why these off diagonals are here. Sometimes I recommend just deleting these because they really don't hold any unique information. It's kind of like, well, of course, a variable is going to correlate perfectly with itself. Okay, but what we're really interested in is looking at both the correlations between the selection tools themselves, as well as the correlations between the selection tools, or each selection tool, and our criterion. And remember, our criterion variable here, which is our job performance indicator, is customer service. So if we look down at this row here, it's the last row that corresponds to customer service, we can see the correlations between each of the selection tools, so proactivity, emotional intelligence, and SJT, in relation to customer service. So this correlation between proactivity and customer service, this correlation of 0.39, this is an indicator of criterion-related validity. In other words, this is a validity coefficient, okay? Now, we're going to assume, for the sake of explanation here, that all of these correlations are statistically significant. It's beyond the scope of this tutorial to explain null hypothesis significance testing or significance testing in general. So we're just going to assume these are statistically significant, and thus we will focus on just the size and the direction or sign of these correlation coefficients. Now notice these are all positive correlation coefficients, which indicates that as scores on the selection tool grow higher, so do scores on the criterion, which is customer service. So in other words, people who are higher in proactivity tend to be better at customer service, is what this correlation is saying here of 0.39. Now, how do we qualitatively describe how big this correlation coefficient is? Well, that's where there's some conventional benchmarks or rules of thumb that we can use to interpret the size or the magnitude of a correlation coefficient. So here I'm toggling over to the written version of this tutorial, which I recommend looking through as well, because it does have this useful information here that I've added, which is the rules of thumb for interpreting how big a correlation coefficient is in the context of assessing the criterion-related validity of a selection tool. So as you can see, we would consider any correlation coefficient that is 0.5 to 1, where 1 would be a perfect positive correlation, anything that ranges between 0.5 and 1 to be large, anything between 0.3 and 0.49 to be medium, and anything between 0.10 to 0.29 to be small, and anything that is less than 0.10 would be negligible, or we wouldn't really care. It's probably not going to have much impact for us, okay? In terms of value, in terms of adding predictive accuracy, in terms of who is going to be the best performer, should we hire them, and based on the decisions we've made using these scores on these selection tools for that given applicant. Okay, so given this, we can see that our correlation coefficient we found between proactivity and customer service a moment ago was 0.39, so that would fall in the medium range here. So we could describe this correlation coefficient as medium. Okay, the same goes for emotional intelligence here. It's 0.43. Its association with customer service, in other words, its validity coefficient is 0.43, which is also medium. And the same goes for the SJT in relation to customer service, whose correlation coefficient is 0.42, which is also medium in magnitude or size. So all three are medium in magnitude. So this we'd probably be pretty excited about this. Now, the next step, though, is we want to make sure that each one of these selection tools is actually unique and that it's not overlapping or redundant with one of the other selection tools. So think about this in terms of cost. And cost in terms of both financial resources of buying access or building these selection tools or implementing them, as well as the cost in terms of time spent by the organization administering them, as well as the time spent by potential applicants taking them or participating in these selection tools. So we can look at these correlation coefficients here. In this correlation matrix will be the correlations between each of the selection tools with other selection tools. So here is the correlation between proactivity and emotional intelligence. It's a medium-sized correlation, which is actually fine. We expect a lot of these things to correlate somewhat. The correlation between proactivity and SJT, the situational judgment test, is 0.24. So this would be about a small one. That's fine. Where we get concerned is with this third correlation between the selection tools, and that is between emotional intelligence and SJT. The correlation coefficient is a whopping 0.93. That is very big. In fact, a general rule of thumb is if a correlation is plus or minus 0.85 or greater, it indicates likely that the two variables that we're correlating are practically redundant or may even be measuring the same thing. This is especially given that these are each measured with error. So this is actually probably, if we were really able to measure these truly accurately without error, we would probably have an even higher correlation coefficient here that would be even closer to 1, which would be a perfect positive correlation. So a correlation of 0.93 would be very concerning here because it's above 0.85. And so why should we care about this? Well, what it's probably telling us here is that the SJT, the situational judgment test, is probably picking up on the emotional intelligence of the job candidates or applicants. And so this is saying that it'd be kind of a waste of our resources to implement and use both emotional intelligence and SJT. They're practically redundant. They're practically measuring the same thing. So in this case, we'd probably look at, well, how much does it cost to implement emotional intelligence? How much does it cost to implement the SJT? And go using that information. In addition, we might also figure out and identify how much applicants or how applicants react to each one of these. If applicants really dislike one of these and they're about the same cost to administer, go with the one that applicants favor more. Because just because you administer something to an applicant doesn't mean that, you accept them based on certain scores they've had on selection tools and make them a job offer, doesn't mean they're necessarily going to accept that job offer. So in some ways, the experience an applicant has or their reactions to our selection tools in the broader system can have important implications for whether or not they accept a job offer and what they tell their friends about applying to your organization. Okay, so to sum up, in this context, by themselves, each of these selection tools here show strong criterion or medium criterion-related validity with respect to the criterion of interest, which is customer service, And we do find that emotional intelligence and the situational judgment test seem to be redundant, so we'd want to drop one of those. Okay, so as I mentioned, let's go back here. There's a second option for when it comes to creating a correlation matrix if you don't have access to Microsoft Excel for Windows. And so how do we do that? Well, we're going to have to make this this correlation matrix from scratch. And so what do we do to do that? Well, we're going to first do proactivity, then we'll do emotional intelligence here. So we're just going to list all the variables we have access to, SJT, customer service. I'm going to widen this column here. And the next thing I'm going to change this to bold text here. Okay, so you can do this in different ways. You could go up here and click bold. And then I'm going to copy this text. And then I want to make it into column labels too. And so to do so, you can see this paste option here. If you do a right click, if you're using Microsoft Word, or I believe this is a command click, perhaps if you're using a Microsoft or a Mac OS operating system. And you'll see that we have this option here with paste options called transpose. So if you click that, now we've transposed. And so we've turned what was a vertical list into a horizontal list there. And I'm going to spread out the cells here. Okay, so how do we calculate the correlation coefficients without using that analysis pack? Well, it's really pretty straightforward. So let's just come to the first unique correlation here, which is between proactivity and emotional intelligence. Do equal sign, and then type in correl, all caps there. And this stands for correlation coefficient. And then do the first parenthesis. And so your first argument in this function here, this correl function, is going to be to select all of the data. And so make sure you get all of the rows of numeric data there. So you don't want to get the column name here. You just want the numeric data. And then type comma. Okay, so this is our first argument here, is this array of cells for proactivity. Now the second array is going to be for emotional intelligence. So to do that, we can just come over here, select that, scroll back up here. Okay, and so this is our second array here. So now we've said here are two sets of arrays and we're going to correlate these together. Okay, and I'll do the closing parenthesis here and hit enter. Okay, so there's our correlation coefficient there. Now we're going to repeat this process for each of the correlations, the unique correlations here, which comprise the lower diagonal. Okay, so what quick way you can do this more efficiently is now that we have this, let's copy this function we created above, this formula we use. And now for the next correlation between proactivity and SJT, we're going to paste it here. Okay. And so now we want to reference proactivity. So that's already referenced here in the first array, but then we also want to reference SJT. So all we're going to do is change these C's or these B's to C's. Okay, so now we're referencing column C here. Click return. And now we're going to go down to proactivity and customer service. We're going to paste that same script we had before, and we're going to change the B to a D here, because now we want to reference that D column, which contains the customer service data. So make sure you change D in both cases there. Okay, so now we've done that. And now we just have 3 more correlations to go. So the next thing I'm going to do is I'm going to go to this cell that corresponds to emotional intelligence and SJT. Paste there. And so in this case, notice that we already have emotional intelligence B, this cell, highlighted, but now we need to do in relation to SJT. So we need to change the A here to a C and the A here to a C to reference that C column, which corresponds to SJT. Hit enter. So there's where we see that huge correlation we saw before. And then we're going to come down here to emotional intelligence and customer service. We're going to paste. Okay, and we're going to do the same thing we did below here, but we're going to change the A here to a D to reference the customer service. So the 2 A's become 2 D's there. So now we have the correlation that we're looking at between emotional intelligence and customer service. Let's hit enter there. And then finally, we have one last correlation to compute by hand here, and that's between SJT and customer service. So let's go up here after we've selected that cell and click paste. Okay. And so now we are going to have to change all of these references here. So let's do C, change the A to a C, and the A to a C, and the B to a D, and the B to a D here. So now we can see we're going to estimate the correlation between SJT and customer service. Let's hit enter. Okay, so these should look familiar here. We can do the same thing we did before, which is we can adjust the number of decimal points. So I'm coming up here to the number area, and I'm going to decrease the decimal points to 2 after the 0. Okay, and so now we have created a correlation matrix from scratch. So you can do it in different ways. As you saw, we used the analysis pack over here, and here we did it by scratch using that coral function from Excel. And it's the same function that you would also find in Google Sheets as well. All right, so this wraps up the tutorial on how you can calculate and compute a correlation coefficient, and even more broadly, a correlation matrix, in order to assess the criterion-related validity of different selection tools with respect to a criterion of interest. Thank you.